Right. So the first third of this class, I was giving you the outline, right? That for the past several weeks, we've talked about AI, understanding modern AI as you following through this arc of development where you have language tasks and vision tasks, okay, or pattern recognition, predictive AI, and so forth. And then I said, well, a lot of this depends on, the three paradigm of machine learning, right? The three paradigms of machine learning: unsupervised learning, supervised learning, and reinforcement learning. That kind of like is inspired from what happened with a human child. Okay, you can say that, right? The key thing is that you work with the original variable, you do something with it, and then you're still working with it in a way. There's something in between, but you really don't need to see it. It's not produced. It's kind of like hidden. Sometimes this is why people say that this neural network is a black box, because you don't see what happened in between. Well, with the fourth machine learning paradigm, most, if not most, modern AI algorithms is this called representation learning. So yeah, you still want to do that, still want this. Okay. But introduce intermediate steps. Okay. That word, yeah. Oops. Okay. You still want this, but introduce intermediate step. So this thing, this intermediate, this part is the representation learning. Okay. Why does it matter? Why it matters? Because AI, okay, first of all, okay, modern AI performs tasks really well in the lens. Often, let's say often, or better, really well, or much better, if done in latent space first. Yeah. And two, you can generate related example, hence the critical, the very key. Yeah. Yeah. Okay.
ภูมิใจครับ I'm so sorry. I'm not sure that you are sharing the screen or not right now.
Oh, okay. Thank you. Sorry. Okay. There. Okay. I just added a little bit of additional explanation. Okay. So let's quickly just talk about this. Okay. So before the break, before the quick, breather, I said that so far we've been talking about the timeline of AI being based on vision tasks and language tasks, right? And I did also say that most of the machine learning paradigm, the three main machine learning paradigm, is based on what a human child does. Okay, inspired by human child. So the infant, you have unsupervised learning. Toddler, you have supervised learning, and kindergarten have reinforcement learning. The key common theme is that you still end up with something in the sort of like original variable, so to speak. Okay. Now, what happened is along the line came this fourth machine learning paradigm. It's not directly modeled after human child because after all, the intermediate step happens in the child's brain. And the neuroscience is not advanced enough to look inside the child's brain, right? So basically, the child can respond, look at an apple and say apple. So that's input, output, right? So it's something in the real space. But in the child's brain, there's some kind of latent representation. Unfortunately, we don't have neuroscience technology to look inside a human brain. Okay. However, we do have a very good way of looking at artificial brain, how it works. And normally, when you build this model, you really don't care. You don't care. You just build a black box, almost. Okay. So almost a black box. So many people think of F as a black box. Magic. Black box. Okay? You should. It is not. It isn't. Okay? But it looks like that because you never look at it. It's the same thing as a child's brain. A child's brain is actually a black box. It's not a black box in the sense that it's all magic. Okay? It's black box because we don't have the technology to look inside the human brain. Now we're beginning to develop neuroscience. Okay? So come to think of it, a human brain is appears to be exactly that, magic too. Right? Come to think of it, okay? But it's not. It's just you never look at it. Now, what happened with representation learning? By the way, let me make a big word. Unsupervised. Let's make it a capital. Okay. So what happened is you still want to do something like this, but you introduce the intermediate step. Okay, so you have this thing, this intermediate step. The point is that when it does this, it does really well. Okay, instead of doing the AI class on the original number, just try to convert it into some kind of Z space. Okay, and then it does this. Okay, now I'm going to go here. I'm going to start with representation learning, and I'm going to say, hey, this is actually motivated, even though I'm going to talk about this, it's actually motivated by this task, the language. So I'm going to introduce this thing. So what happened? What happened here? Well, this statement, I say, oftentimes AI perform tasks really well or much better if done in latent space first. Okay? Now, I'm going to put another sentence in and say, as a matter of fact, if X is space of language words, AI cannot work on X directly, but needs to convert to Z. Okay? And this is called word embedding. Okay. I'll send you an update version of this. So, okay. I earlier said that, hey, why do we have intermediate step? We have intermediate step because AI is much better doing things here, right? Doing things here. And it's a little bit like, let's say this is a child, this is an adult. So you want to raise a child into an adult. However, if you raise a child in Thailand, because you have everything here, you'll be spoiled. So what you do is you send your child to America, to somewhere else, New Zealand, and then raise him or her there. It turns out that if you did it in another country, because there's no facility to facilitate or help you, you become a lot more mature because you have to help yourself. So the same process you want to raise a child, but if you do it here, life is too easy. So you become like a big baby. I'm not calling you guys big baby. I'm just thinking of my example. If I were raised here, I would be a big baby. So my parents decided, well, I would be better off being raised somewhere far away where I have to rely on myself. So around 14 to whatever, 30, I was on my own, almost, not quite, but on my own. The same process, I became adult, but my growth process did not happen in the original space of Thailand, happened in the alternative space of back then United States and then United Kingdom, right? So sometimes the idea is when you don't work on the thing in the original space, you can do maybe a better job or something like that. Okay. However, in the case where we're talking about the original space being the space of words, AI absolutely need you to transform X into a latent space, right? Because what did I say? Because what? Well, AI only input numerical numbers, right? Right? But only works on numerical vectors. Hence, needs to convert to Z, i.e., word embedding. Okay? You guys see that? So, this very thing that is going to be key later on here is actually part of what's happening here. So I'm going to put ... and then I'm going to say word embedding. Okay. Okay. I.e. word to vec. Okay. Now, right now, what I'm going to do is go to here and show you YouTube. I'm not going to show it to you now. How word to vec works. And I think this one is nice. So I'm going to copy this.
On word embedded.
Okay. So I'll send you this guy in the homework. Watch. Okay. Homework today. Homework Okay. Watch this one. Not this guy, not this one.
Language is beautiful, expressive.
Yeah. Yeah. And finally, the third one that I wanted to watch, I think was
We cannot visualize embeddings with
this one's a little bit long. So yeah, I changed my mind. I'll go to this one. Sure. Skip. Now this one is nice, but it's got Indian accent, so it's a little bit hard to understand, but it's actually pretty decent.
Ajahn, we can't see the screen.
Oh, you can't see the screen. Sorry. Okay, I just sent it to the line group. There are 3 videos that you have to watch, and the homework to rank preference, like number 3 is better than number 2, and okay, just look at the line at number 1 and number 2 and why. Okay, stop share. Okay, so now we're back to sharing the whole screen. I'm going to share the whole screen. Okay. 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 So TA, feel free to mark off students and drop off. Or you can't see the face like this one or that one. You can't see, you can just mark it off. Okay. The reason two things. Why am I paying a lot of attention to this class attendance is because there are hundreds of you and I have to sort of like grade you differentially. And because some of you will have the same grade because of the group project. So, okay, I have to basically give you different differential grades. Okay, fine. Okay, so there it is. So the first step to language task is you have to do this. Okay, you have to turn words into you have to turn words into numbers, and that's what word to vec means. Okay, literally, word converts to vector. Okay, word to vector. Now you can ask ChatGPT or Google, okay, dimension of word embedding used by GPT 3.5. Yeah, I think this is the number. Okay, 12288. Original word definition uses thing. Okay, so actually, I'm going to show you this very good application called Demo Geo Word Embedding. There. Okay. Okay, so now tell you what, why don't we take a 5-minute break? Okay, 5-minute break. I'm gonna refill my coffee, and when we come back, we are going to walk from word embedding to transformer. Okay, we won't get that far in transformer, but we walk from word embedding to transformer. And I will start by letting you watch with me the three blue, one brown video. Okay, so let's stop here.